Lesson 7.1, factors and greatest common factors. Well, this is my second time to video this lesson today because I guess I didn't pay attention to my batteries and they just died, so I'm going to record this one again. Here we go. 7.1, factors and greatest common factors. Okay, factors, those are the numbers that are multiplied to find a product. So if I ask you to find the factors of 12, what goes into 12? I know that. 1 times 12 gives me 12. I know that 2 times 6 gives me 12. And I know that 3 times 4 gives me 12. Okay? Those are your only factors of 12. If I ask you for prime numbers, those are the only numbers where it in itself are the only factors of that number. So 2 would be prime because 2 times 1 is 2. That's the only thing. 3 would be prime because 3 times 1 is 3. Those are the only factors that make up 3. And those are your only prime numbers there. So let's practice writing prime factorizations. Write the prime factorization of 60. There's 2 methods. The factor tree is my most favorite method. It's usually the only method that I teach, but this particular app introduces the ladder diagram, and we'll cover it here in a minute. But looking at the factor tree, you're going to ask yourself, what are your factors of 60? You're going to try to start with your lowest number possible that'll go into 60 other than 1. In this case, I know it's going to be 2, so I'm going to have 2 times 30. Okay, I'm going to circle 2 because it's prime. This is a 30. Okay, what are your factors of 30? Okay, will 2 go into 30? Yeah, it will. It'll go 2 times, so 2 and 15. Okay, 2 is prime. What are your factors of 15? 3 and 5. So those are your prime factorizations of 60. You're going to have 2 times 2 times 3 times 5. Okay, ladder diagram. We're going to start with 60. Okay, I know that 2 will go into 60 30 times. I know that 2 will go into 30 15 times. And I know that 3 will go into 15 5 times. That's as low as that's going to go. So there's your prime numbers for 60 using the ladder diagram. Again, it would be 2 times 2 times 3 times 5. Okay. The next definition we're introduced to is the greatest common factors. Greatest common factors. It says factors that are shared by 2 or more whole numbers are called common factors. The greatest of these common factors is called the greatest common factor, or GCF. Anytime I ask you for the GCF, that means greatest common factor. So going into example 2 on your app, we're going to practice finding the greatest common factor. Let's find the greatest common factor of 24 and 60. So I need to list my factors of 24. I'm going to have 1 and 24. Will 2 go in? Yes. 2 and 12. How about 3? Yeah. 3 and 8. 4, 4, and 6. Okay? Those are your factors of 24. Your factors of 60 are going to be 1 and 60. I'll just spread them out. I know 2 and 30. I know 3 times 20. How about 4? 4 and 15. Well, 5. Yes, 5. 12. Will 6 go into 60? 6. 10. Okay, those are your factors of 60. So to find the greatest common factor, I can see the greatest number that they share is 12. So 12 would be your greatest common factor. You look at your checkpoint questions. You can, if you're confused with what I'm doing, you have your play video on your app you can look at. And let's look at check it out. Let's find the greatest common factor. Let's do 2A. Let's find the greatest common factor, that's an A. Let's find the greatest common factor of 12 and 16. Okay? So my factors of 12 are going to be 1 and 12, 2 and 6, 3 and 4. My factors of 16 are going to be 1 and 16, 2 and 8. Will 3 go into 16? No. Will 4? Yes, 4 times 4. And that's all. That's all my factors of 16. So if I'm looking for the greatest, we have a 1, 1, 2, 2, 4, 4. So I can see that my greatest common factor is going to be a 4. Okay? How about finding the greatest common factor of a monomial? Find the greatest common factor of 3x cubed and 6x squared. Well, what are your factors of 3? I have 1, 3. X cubed breaks down to be x times x times x. Okay. 6x squared, my factors of 6 are 1 and 6, 2 and 3. X squared breaks down to be x times x. I can see my greatest common factor is going to be 3. I'm going to write down 3. And I can see that they have 2 x's in common. Okay, so x times x becomes x squared. There's your greatest common factor. Moving on to B on example 3. I have 4x squared and 5y cubed. What are your factors of 4? I have 1 and 4, 2 and 2. X squared breaks down to be x times x. My factors of 5 are 1 and 5. Y cubed breaks down to be y times y times y. I can see the only common factor that we have is 1. That is your greatest common factor. Looking at your checkpoint on example 3. Okay, let's do 3A. Good grief, I can't write this one. I can't even read my own handwriting. Find the greatest common factor of 18g squared and 27g cubed. Okay, so 18g squared, 27g cubed. What is our greatest common factor going to be? Okay, well 18, my factors are 1 and 18, 2 and 9, 3 and 6. Okay, g squared breaks down to be g times g. My factors of 27 are 1 and 27, 3 and 9. G cubed breaks down to be g times g times g. So what is my greatest common factor that I see? I see 9. Okay. And this has 2 g's, and here we have at least 2 g's. So g times g is g squared. Okay. And then example 4, our technology application. You need to go to example 4 on your app on chapter 7, lesson 1, and follow along with me. Because at the beginning of the chapter, it asks who uses this. Well, website designers who sell electronic greeting cards can use the greatest common factor of numbers to design their websites. Okay, so let's figure out how they can do that. Looking at example 4, technology application. You can see that this page that he's wanting to design, he wants a row of special, he wants however many rows of special occasion, and he wants however many rows of birthday designs. It says Garrison is creating a web page that offers electronic greeting cards. He has 24 special occasion designs and 42 birthday designs. So 24 special occasion and 42 birthday designs. The cards will be displayed with the same number of designs in each row. Special occasion and birthday designs will not appear in the same row. How many rows will there be if Garrison puts the greatest possible number of designs in each row? Well, it has to be a number of designs that they have in common. We're trying to figure out how many designs in each row. So I'm going to have to find the greatest common factor. So my factors of 24 are going to be 1 and 24, 2 and 12, 3 and 8, 4 and 6. Your factors of 42 are going to be 1, I'm going to spread it out since it's a little bigger number, 1 and 42, 2 and 21, 3 and 14, 6 and 7. I guess I need to spread it out that far. But our greatest common factor, they share a 6. Is that the greatest common? Yes, it is. So, the most designs that they can put in each row is 6 designs. Okay? So now, how many rows can we have of special occasion? I have 24 special occasion. I can put 6 designs in each row. How many rows am I going to need? 24 divided by 6, I'm going to need 4 rows. Then I have 42 birthday designs. I can have 6 designs per row. I'm going to need 7 rows. 42 divided by 6 gives me 7. So how many rows total am I going to have on my page? I'm going to have 11 rows. Okay? And here's your assignment for this lesson. It's going to be 17 through 35 odds and number 56.